I'm Ava.
And I'm Beth.
This is Calculus AB.
Are you ready to graph this function? I am.
Finding the critical points. The critical point is when the first derivative of a function is equal to 0. So here we have f of x equals x squared plus 4x plus 5. I made a little table and I graphed it. It's a quadratic function. And then using the power rule, I took the derivative. So it's 2x plus 4. To find the critical point, you set that derivative equal to 0 and you solve for x. When f prime of x equals 0, x is negative 2. So I plotted that point and I drew out the actual graph of the derivative. And if you look at the original f of x graph at x equals 2, it's a minimum on that graph. And that's also a way to tell if there's a critical point. Any minimum or maximum on your original graph is going to be a critical point because the slope would be horizontal, making the derivative equal 0.
Inflection points. When f of x changes concavity. So the first step is to find the second derivative. So you take two derivatives of the original function. Then you make a line chart, which I showed above with the second derivative. For this problem, x equals negative 2 is an inflection point because f double prime, or the second derivative of f, goes from negative to positive there. Note, there must be a change in concavity, so f double prime of x goes from negative to positive or positive to negative at the inflection point. Graphical approach to concavity. So we have the function f of x equals 1/3 x cubed plus 2x squared plus 3x plus 12. Now we know the inflection point was at negative 2. We found that in the problem above. And the concavity changes at that point because that's the inflection point. And this is just the graph that shows the change in concavity because it's changing from concave down to concave up.